Well, hello, welcome to 24 Hours of Past Summit Preview 2018. We're excited you could join us today for two industry luminaries, Brent Ozar and Erik Darling, giving their session Why Performance Tuning Wisdom Needs Expiration Dates. This 24 Hours of Past consists of 24 consecutive live webinars delivered by expert speakers from the past community. The sessions will be recorded and posted online after the event. You will receive an email letting you know when the recordings are available. My name's Dave Noderer. I'm a software developer and MVP in South Florida. And I have a few introductory slides before I hand it over to Brent and Eric. Click. This is our secret word. If you require technical assistance, please type your questions in the question pane located at the right side of your screen, and someone will assist you. The question pane is also where you may ask questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to the speaker. You're able to zoom in on the presentation content by using the Zoom button located at the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. And it will pop up after the webinar ends in your web browser. Click. I'd like to take a moment to thank our presenting sponsor, Quest. In the staging of 24 Hours of Past would not be possible without their generous support. And they are the reason this event is available free of charge. If you would like to learn more about Quest and sign up for information on how they can help you, please visit the sponsor page of the 24 Hours of Past website. Click. PASS is a global not-for-profit association where data professionals connect, share, and learn. Joining PASS is free and gives you access to hundreds of hours of free online content, live, virtual, and in-person events, the ability to join local groups in your area, and the opportunity to attend the annual conference PASS Summit. PASS is a great way to connect with like-minded professionals and increase your technical expertise and grow your career. Click. And without further ado, here's Brent and Eric. Take it away.
Howdy. Thank you very much, sir. So today, Eric and I are going to be talking, well, one of us is going to be talking. Eric is not going to be talking, as you can see by his little microphone up. Eric is, well, we'll get to the intros here in a minute, but we're going to be talking about why performance tuning needs expiration dates. I'm Brent Ozar. I'm the co-founder of Brent Ozar Unlimited. I specialize in making SQL servers faster and more reliable. And man, all I do all the time is I read. I read so many books about SQL Server, so many presentations, sit and watch webcasts. Man, I read so much. And it's amazing what you can get, even if you don't have much of a budget. I picked this book up out of a bookstore for $2.99. Now, it's not exactly new. It's a book on SQL Server 6.5. But SQL Server knowledge is timeless, right? I mean, as long as I learn it once, we should be pretty well good to go for a really long time. Now, everything that we're going to talk about here today is down at brentozar.com/go/24hop. The scripts are already there. The slide decks are already there. We just only put that URL up once during the session, so that's it. Now, the next person that's involved is Erik Darling, and I'll do his intro because he's my employee, and who wants to bother hearing him talk? You know, I hear that it's really trendy these days. Microsoft's always talking about how the robots and artificial intelligence are going to take care of everything. So I got myself a robot. Erik is like, I think of it as an automated meat bag. He'll do whatever I tell him to do, and he's going to be doing all of the demos today. And you won't hear him talk, but I kind of got a simulation here. I don't know if you remember that there are these things called speak and spells, and it turns out that there's a speak and spell app for your phone. So I'm going to give you a simulation of Eric's voice here in a second. SQL. See, that's exactly what Erik would sound like if he had his microphone up and running. Now, the best way to go through and learn SQL Server is, of course, demos. So we're going to switch over now into SQL Server Management Studio. Screw the slide deck. Let's just purely show you exactly how SQL Server works. Man, it's one thing to go read knowledge out of a book. It's something else entirely to see it in action. We're going to be using the Stack Overflow database, the public open source database that you can go download, has all kinds of stuff like Stack Overflow's users, posts, comments. And Eric has already set on common performance tuning options like turning on his actual query execution plans. He's turned on set statistics IO so that we can see the impacts of the queries that we have. I'm going to start with some basics here, some stuff that I probably don't even have to tell you. For example, table scans. Say, for example, table scan is the reading of each and every page of a data page of a table. Now, when you read an entire table, this can take a while with a large table because of the number of pages that SQL Server has to read. It's the table size divided, it says divided by 2K. I don't think SQL Server has 2K pages anymore, but that's not important. Logical reads, that measures out how many of these pages that we're going to read. And when you see a table scan, you're reading the whole entire table, no matter what. Whenever you see that execution plan icon or any kind of thing that says table scan, that means you read the whole entire table. You'll never see a query that doesn't do some kind of filtering like a where clause that doesn't read the whole entire table. It says right here, each and every single page. So of course that's Eric's got a cheat on there. Oh yeah, now let's do a filter. That's a great point. Man, my robot thinks of the best demos. So let's filter, because when you don't want to read the whole entire table every time, you only want to read parts of it. But unless your query has an index, when you see this evil clustered index scan, that means you read the whole entire table. That's what that clustered index scan means. Now, we only want, in this case, 50. We only want 50 rows, and we specifically want where reputation equals 1. That's a filter. And then we're sorting by reputation equals 1. I don't have to tell you, you've read as many books as I have, that when you're doing filtering and ordering by, you need an index on that field. You can't afford to scan the whole entire table every single time that it runs. So when we look at that, when SQL Server builds that execution plan, clearly it needs a better way to access that data. That's where indexes come in. When you create an index on a field, like say reputation, SQL Server is going to use that index automatically. You don't even have to do anything. This is one of my favorite things about SQL Server, and they talk about it right in here. They say, here's the bombshell. SQL Server almost always chooses correctly when it comes to indexes. Let's make that point again. In the opinion of almost everyone we know and every book or article we have read, the SQL Server Query Optimizer almost always chooses the optimal path to retrieve the data. Here, SQL Server instantly uses our index as soon as we run the query. When you look at that execution plan, well, that's not right. Wait a minute. SQL Server didn't use the index, and we created the index, and it's choosing to scan the entire table. Why would it do that? Oh, you know what it is? Eric, I bet you haven't freed the plan cache recently. I've been told in here that if I make lots of changes to a table, if I implement the right indexes or whatever, I should run dbcc free proc cache. What this lets SQL Server do is start a fresh plan and build a new execution plan from scratch. It didn't know about the index when it built this execution plan. So we want to free the plan cache to tell it to choose a new execution plan based on our query. It still chose to scan the entire clustered index. Well, that seems odd. Okay, well, SQL Server is not always perfect, right? It said almost always perfect. So maybe what we should do is we should force the index. I've read in here somewhere, let me go find it, index forcing. Yeah, here we go. If you're sure you're right, and of course I'm right, you can force SQL Server to use the index that you believe to be the correct one. And I do. I've seen people do this exact trick. I know I'm right. I know that index is always going to be there. So let's give it a shot and see how much faster it is. Now we get the index seek that we always wanted. I guess that pesky SQL Server is just not not quite as smart as he thought he was. So we get an index Sikh directly into that brand new non-clustered index that we created. Surely this query has to be cheaper than the other query. SQL Server's got this cost-based optimizer thing where it compares different execution plans and their costs. Costs are made up of a lot of factors. And then it can decide based on those costs which one is less expensive. Here in this case, well, that seems odd. So the cost of scanning the whole table, of reading the whole entire table, is 6% of this. But the cost of doing just an index Sikh is like 15 times higher. You know what it is? So it's really cool how SQL Server builds these costs. It includes things like the number of logical reads that the query is doing. Maybe that index Sikh plus the key lookup, that's way more logical reads. So the top line is the first query. The top line is when it went and did an entire table index or a clustered index scan across the whole entire table. Well, this doesn't make any sense either. So here, SQL Server, the second query, the one that's only doing 165 logical reads, where we forced the index, SQL Server saying that that's actually less expensive. Well, it's not though. It's saying that it's less logical reads, but it's more expensive in terms of query. You know what I've heard? I've heard that you're not supposed to judge queries by estimated execution plan cost, that's not always a repeatable measure back and forth, that sometimes execution plans will cost different amounts. Instead, the technique that you should use is to measure the number of logical reads that are coming out of the query. Number of logical reads is whenever SQL Server does an 8K page scan or reads one of those 8K pages, it's going to be exactly the same number of logical reads every single time. Well, so clearly the second query is going to be the cheaper one in order to run. So let's measure it with over and over again. Let's make sure that it always runs and returns the same number of logical reads. This is one of the cool things that I love about logical reads. It doesn't matter what's in the cache. It doesn't matter how big your server is. It doesn't matter if it's been restarted recently. Logical reads is totally different from physical reads. I've been told in here repeatedly, don't rely on physical reads because physical reads will change all the time based on what's in cache. But logical reads will always remain consistent no matter what happens to be in cache. That's the way that you should measure the success of your query. Man, it looks like, I don't know what my tuner's doing there, my robot over there. He's made the query 10 times worse, whatever he just did. Who knows what he just did? The query made it 10 times worse. He should maybe go back to looking at the execution plan. Look at these two execution plans. They're identical. It doesn't matter what's in cache, what's not in cache here. As long as you have the same query that's run over and over again, it doesn't matter what's in cache, what's in the buffer pool. It's always going to return exactly the same number of rows from each operator. What he's going and looking at there is the how on earth? Number of rows is 449. Our query only got top 50. Wait, what? So the top query has number of rows 50 and the bottom query has 449. Did you play around with the queries when I wasn't looking? Did you maybe do top 500 in one and top 50 in the other? No, they're both top 50. But after we do dbcc drop clean buffers, we're returning a different number of rows from that plan operator? So I think he's telling me that for some reason, when I run the query at different times, I might actually even get different numbers of logical reads. So this even impacts what I'm doing in my development servers. Okay, I don't know what's going on here. I'm starting to lose my faith. Let's just go back to the original query, just the top 50, order by reputation, just no index hinting. Let's go back to something really simple. And what I bet it is I've been reading about this in here. Logical reads can get into worse shape whenever your table is heavily fragmented. So I bet what we need to do is we need to set fill factor to a lower number. For exactly, and yeah, see right now it's 671 logical reads. After we rebuild this and we set it with the right fill factor, it's going to be much better. Eric, trust me, for my expert blog reading, I know that a good fill factor is 80%. Here's why. It tells you here inside this. It says the rule of thumb is this: use larger fill factors for tables that have data that are not likely to change, and smaller fill factors for tables that only have a small amount of data that they will eventually hold. You don't want to have your pages to be 100% full. That leads to page splits and really bad query performance. What you need to do is set fill factor at a lower number so that your queries go faster. So that's why I always recommend that people set their fill factor to 80%. Once we do that, then we're going to have less impacts on all of our queries. Instead of reading, say, 600 and some logical reads, things will surely get, oh, they're not better. Oh, I don't think they said that in the book. I think they wanted us to set a lower fill factor. That's really weird. SQL Server's default fill factor is 100, but I've read all this out there that you shouldn't be doing that. You should set it at other numbers for better performance. How can this thing get worse? All right, look, forget it. Let's forget that. We'll go to an entirely different demo. This is a bad idea. Let's start by dropping our indexes. And for those of you who haven't seen out there, we have an open source stored procedure called drop indexes. It's really important that you do it too. And I've got a great example of why here out of this book. This book says, remember that the first few indexes hurt the most on update performance. If you have just a clustered index, a write only affects one page, but the first non-clustered index means 2 pages are impacted and there's 100% more work. The point is that when you add more indexes to a table with half a dozen indexes, it doesn't affect you as much. So I'm really scared to put on just say 1 index or 2 indexes on a table. That's not so good. I'm going to go back to none here and we'll try a different query. Hey, Eric, let's try filtering on, say, display name. Let's find, I should start calling him Cortana. It should be kind of interesting, call him like my robot would. Cortana, find me the users. Oh, I love that. Named eggs, that works. Call him Tay. Oh yeah, Tay was a social media superstar there. So this one, SQL Server, I bet will ask for a missing index right away, because look at that query. It's doing this CPU intensive string shredding. It's going through display name and looking at every one of them to see if it's like eggs, and then see how that trailing percent sign is. That means surely we're reading the whole entire table. This isn't sargeable. It's going to scan the whole entire table, doing tons of CPU work every single time. In SQL Server, going through string fields and examining them is very CPU intensive. And of course, I buy my robot nothing but the best hardware. So he's got a big, beefy monster box. Let's throw more CPU at this thing, Eric. Let's use option max stop equals 8. Now, when you use option max stop on there, this lets you throw way more CPU power. You can even override the server's level max stop. Doesn't matter if the server's level max stop is set to 8. As soon as you throw on option max stop, your queries can have a party in the CPU cores and everyone is invited. When you throw that in, you start to see this parallelism operator in the query plans. This parallelism operator, along with what Eric calls racing stripes, will appear on every operator that's going parallel. So it's an easy black and white thing to see. As soon as you throw in that option max stop hint, immediately your queries can go, say, 4 or 8 times faster. Now, of course, to make this query go even quicker, we could throw an index on display name. I'm kind of surprised that SQL Server didn't recommend an index on display name. It seems like SQL Server is always really eager to add indexes on display name. What are you typing there where 1 equals what? So that's odd. So Eric just added in something in the query that doesn't even talk about display name. He added in this where 1 equals select 1 and all of it. I don't think that I've got that in my book. Hold on a second. Let me go look. I'm going to check in the index for like missing index hints. It seems really odd that when you put in where 1 equals select 1, that all of a sudden, see, it's like there's undocumented, this whole book's full of undocumented stuff. One of these must talk about the secret 1 equals select 1 hint, or maybe making SQL Server give more missing index requests. What is this? Because without the query, all of a sudden, maybe it's a hint that tells that enables, maybe it's like turns on a trace flag behind the scenes. I've never seen anything like that. I just don't know why adding 1 equals select 1 would cause the query to work harder. That doesn't make any sense. Well, maybe we should just think about adding it in all of our queries. That's pretty cool. I wonder if it'll actually work. Hey, Cortana, create the missing index. Let's see if it works. Now, if we create this missing index, maybe SQL Server won't even use it if we don't put the hint in. It did use the index. Well, oh, that's really cool. So just to recap what we just saw, Eric had a query that was, pretty straightforward. It was obvious the thing needed a missing index. It was black and white obvious. And then he added in this sorcerer hint of where 1 equals select 1. I tell you what, I'm going to add that to my own notes at the back of this book about the things that I need to do on a regular basis. I bet I should add where 1 equals select 1 at the end of all of my queries. So that's pretty doggone cool. I think we've all learned something today. Hey, we should try it with another field. Let's do, hey, Cortana, drop my indexes again. I got to make sure that I drop my indexes on a really regular basis. I don't want a bunch of extra indexes lying around. And then let's filter by reputation. Let's try another query and let's go sort just for, say, reputation equals 2 or something. All right, great. So this will now, we got 2 different queries here. We're both filtering for reputation equals 2. Let's see if Eric's magic hint turns on missing indexes because the queries are identical. It does. Clearly we've learned now. So let's write that down as our next new best practice. In every query that we build, we should go through and add where 1 equals select 1, and that turns on missing index recommendations in query plans. I'm just going to go through and add this just across the board as one of my all-time favorite rules and backdoor query hints of what I should do with my SQL Server. Where 1 equals select 1 must cause SQL Server to spend more time somehow building missing index requests. It's like a missing index request cheat code. That's pretty awesome. Let's see if it works on more challenging, like real world type queries. Hey, Cortana, in the posts table, get me a count of posts by post type ID. Let's see here. Oh, man, I love it. Cortana is just amazing. I'll have him type out SQL again. Oh, let's see here. SQL. Awesome, I love it. So we have here, post is a larger table in Stack Overflow. Post contains all of the questions and answers. Now we're dealing with the kind of cut down version of the Stack Overflow database here. So the query still runs fairly quickly. However, this is a hard query to run. It's going to go through and scan all of the post table because you see us continually dropping indexes, making sure we don't have any left on the table. Scanning the entire clustered index on the post table is a big deal. And I don't have a where clause here. I'm reading the whole entire table and grouping them all together by ID. Now, I often make fun of Clippy, the missing index recommender, but he's empty here. Again, he says, go through all of the post table, grouping all of the posts together by post type ID. If you look at that query plan, it's got a couple of things interesting in it. It's got a hash match and it's got a sort. I adore these little icons because they explain to you what SQL Server's doing. The hash match says, I'm putting every incoming row here into a bucket. So every time we see a new post type ID come in, I'm going to go stick it into a different bucket. Hash matches are for unsorted data. Like the post table is not organized by post type ID. The clustering index on posts is on just the post ID. Type ID in here is in effectively random order. So all this data is streaming in here effectively randomly. The first thing the SQL Server has to do is go put those in order by post type ID. Well, order's the wrong way. It's going to group them together by post ID. Then we have to turn around and do a sort, which I tell you what is my personal enemy in execution plans. These things are like kryptonite. I want to do anything I can to avoid having indexes in or having sorts inside my query. This has told me over and over again, sorts are so expensive in terms of CPU. I bet you've seen a lot of those with yellow bangs on your query execution plans too, showing that the sort spilled to disk. Sorts are just absolutely evil. It's amazing to me that with all of this really heavy lifting going on, just like the heavy lifting Eric does, Cortana, show them your arms. Holy cow, guys. This is why I make him live in Brooklyn and not near me, because he'd kick my rear every time we did an employee evaluation. Call me a robot again. So I bet SQL Server would really be able to use a missing index here. And I'm kind of stunned that it didn't, or didn't ask for one. So what we'll do is we'll use Eric's magic hint here. We'll throw in where 1 equals select 1, and then I bet we're going to immediately get an index recommendation now. Maybe it's running the index tuning advisor or the database tuning advisor. I used to love when you would run the index tuning wizard, the little guy with the cloak would show up. He would solve all my problems. He was like Voldemort or whatever that Harry Potter guy is. So the where 1 equals select 1 is going to immediately throw in that index request that SQL Server was hiding for me before. That blows. So we're still doing a clustered index scan, and this query is harder than the ones were before. This query is even more work. Oh, and we have those nice racing stripes that we were talking about earlier. SQL Server's automatically thrown in multiple cores against this query to make it knock out and run through quicker. Maybe this query isn't such a big deal. Maybe it's not doing more logical reads. Maybe it's hardly doing any logical reads at all. Maybe it's a super lightweight query and it doesn't even need, no, that needs an index. That's 800,000 logical reads. Remember, that's even more pages than this book has. This book has 850 pages in it. It's like this book times 1,000. We're scanning through that many pages in order to find the rows that we want. We need an index. So here's where my secret weapon here, Eric, is even smarter than the query optimizer. I can say, Cortana, go design the right index for this table. And now, just like that, he does it. He immediately, he's so smart, not to mention handsome. So he's created this index. And now let's see, as we go through and run that query again, let's go see if it works. I bet it won't even use the index because SQL Server didn't ask for it, even when we had our missing index hint in. Oh, no, it does. So, well, I assume that it does, but that's what I'm so bad at math. It's not even funny. That's 80 times less logical reads. And it's using the index that Tay created. Now it's doing a scan, which, of course is, hit or miss, but it went from like 800,000 logical reads down to just 6,000 logical reads, even though it didn't ask for a missing index. I guess we all need one of these, magic robots over here on the side in order to design indexes a little. That's so funny because I could have swore I had already thought about where I'm going to stick my 1 equals select 1 thing inside this book, and it doesn't look like it's actually working. Well, look, so as we look at that query, some of the other problems that are involved with that query, just in the query plan in general, is I don't really like order bys. And I'm kind of torn about this, see, because I have two fields or two frames of thought. One is what's in this book here, and this taught me and took me quite a long way. It says in the order by section, you always want to include an order by statement because even when a table doesn't change its structure, the default order in which the rows can return can change. Always use order by in a clause to protect yourself against these changes. Always use order by on a query that will return more than one row. All my queries return more than one row. But at the same time, I'm kind of torn because I don't want any more work to be done in the database server than I can afford. Database servers are expensive. Oh my God. SQL Server Standard Edition, $2,000 a core. Enterprise Edition, $7,000 a core. I want as little sorting inside my execution plans as possible. So what I've told my minions over there is when you write a query, so help me, you had better not ever have an order by inside your query. Because if you put an order by inside your query, it's going to have a sort in the execution plan. And if I see a sort in the execution plan, that means you weren't writing queries correctly. It means your indexes aren't designed correctly. As long as we don't have an order by in that select statement, we're not going to have to deal with any of that CPU expensive sorting. So let's see here. What's he doing? He's saying, show me the query there. What is it that you're running? So he's got us, oh, this is good. So there's a select and there's no order by. This is exactly how I want Eric to write his queries. Oh, it's got a sort. Well, now that's odd because there's an index that perfectly supports this query. Eric's index was on creation date and then order or owner user ID. We're searching by creation date. Then we want them grouped together by owner user ID. Oh, they're not going to come out in that order, are they? Since we want all of the dates in a range, and the first field of the index is based on the range, and the second field is the owner user ID, then SQL Server is going to have to sort it. Did you put an order by in there? There wasn't an order by, Bo, but you have a group by. I guess in order to do grouping, we have to sort stuff. For example, let's say if I wanted all the index tuning pages out of this book, and I only wanted to group them together by topic, maybe, like I wanted the index tuning stuff in one section and the query tuning stuff in another section and the undocumented trace flags in another one. I guess I would have to sort them in order to group by them. All right, Eric, new rule. I'm sorry about that. I've been wasting your time for the last couple of years. Group by and order by. Now we're going to ban both of them. You're not allowed to do a group by and you're not allowed to do an order by. As long as we don't see either of those, we should be good to go. We won't have any sorts in our execution plan, and those sorts are just so god-awful expensive. So here he's got, what? Select distinct name from posts. It's doing a hash match and it's doing a sort. Oh man. And the sort's even got a yellow bang on it. The sort has a yellow bang on it, which means it's spilling to disk. And I didn't ask for grouping and I didn't ask for ordering. I guess it makes sense when you say select distinct, because if I want the distinct values of something, then I have to sort them to find out if there are any dupes. I'm starting to wonder if there's anything that we can run in SQL Server that doesn't produce a sort and doesn't spill to disk. You know what else is really odd? If we're doing a select distinct, why isn't it asking for an index? Because it's scanning, I gotta guess, how on logical reads? How do we do on logical reads on that? They must have scanned a whole bunch of stuff. It's a clustered index scan. It read 800,000 pages again, 1,000 copies of this book it read in order to execute this query. And SQL Server's not asking for an index. All right, we know the drill now. Cortana has this magic hint. Cortana, add the missing index hint, and let's go see what we get. So now all of a sudden SQL Server is going to go give me a missing index for this query and we'll be able to. Wow. So SQL Server still didn't ask for a missing index request. I wonder if it would even use it. Probably not. Cortana, can you create an index on here just to see if it would actually work? Create an index on last editor display name, and then it's not going to use it, I'm sure, because it's a big, ugly query, but SQL Server, no way it's going to use it for a select distinct. It won't know to go through and use that index, especially if it didn't ask for it. I should point home too, this is the same missing index stuff that also is based out of the missing index DMVs. So when you use those missing index DMV scripts that tell you whether or not you should add an index, they won't have anything in here when you're running queries like this because SQL Server's not generating a missing index in. And it's using the index that the robot didn't even need to know to ask for. And now, so it's scanning the index, which granted, I really wish it would only go in and get direct stuff. I've heard lots of myths around Sikhs are always better than scans no matter what. Here, what we'll do after the webcast is I'll make Eric figure out how to make this query do a Sikh instead of a scan. That'll surely make it go faster. But at least it got this stream aggregate here that's going to work better than instead of dealing with unsorted input. And how much of a difference did this one make on logical reads? We were at 800,000 before, and now we're down to 5,000. Geez, this thing got even faster. Well, all right, I don't know about y'all, but I'm ready to give up. This is just ridiculous. We've gotten so many goofy things in here out of SQL Server. I'm ready to go light this book on fire. So much of what I took for granted out of here is turning out to be just absolute bunk. And frankly, dear audience, that's exactly how a lot of stuff works out on the internet. You're going to have blogs that are expired, even my own posts that are expired, things that made a lot of sense 20 years ago, 30 years ago in databases that just don't make as much sense now. You got to stop dealing with that knowledge that you got from $2.99 from a used bookstore. So this is why we're talking about this exact topic at the PASS Summit in Seattle, Washington. So in November, Eric and I are getting together to do an all-day pre-con where I might, if you guys ask for it, let him speak instead of just miming out everything that he has to do. What we're going to do at the PASS Summit is why you need to level up your T-SQL skills. We've got more information about this, how you can go register for the PASS Summit. There's tons of good pre-cons. And I don't care whether you go to ours or somebody else's. The point on this is that the skills that you had 5 years, 10 years ago, they're out of date and it's time to level up your game. Just like Eric and I continuously have to do it, and everybody on our team, everybody out there who's writing blog posts, presentations, all of us end up going to conferences like PASS Summit and sitting in pre-cons. You'll see us when we're not teaching, sitting in other people's classes because we want to raise our games as well. Dave, I will turn it over to you to pop through. And if y'all have any questions, feel free to use the questions pane in GoToWebinar or use Twitter as well.
Yeah, we'll go to questions. And really the only one that came up was, well, for one thing is, what was that book they were looking at? I just answered that it's, go ahead, so.
Oh, I don't want to throw anybody under the bus because God bless them. It was a good book, I'm sure, back in whatever year it was that this thing came out. And I bought like a whole bunch of SQL Server 6.5 books because I wanted to see how much had expired since that time. And it was a laugh a minute. It was really interesting because some of the stuff in there is timeless, is absolutely evergreen. Most tables need a clustered index. Here's why, here's queries work, here's how sargeability works, here's how it maps to hardware. A lot of it, if I had to guess, maybe 80% of it is still gold. But the 20% that sucks, that is just outdated, it's not the author's fault. It's just that practices have changed so much over time. The 20% that's outdated is so outdated. And as a reader, it's really tough for you to decipher which ones are current and which ones are outdated. Every time I opened a page and I read something for you guys, that was word for word out of the exact book. So it's, yeah, Eric says, no wonder people stopped writing books. Yeah, the process is terrible. I know from writing our own book that if I could go back to 10 years ago as we were writing it, I'm like, yeah, a lot of things have changed since then. And it's not the fault of having dead tree books either. Blogs are exactly the same way. There's so many blogs out there that somebody published 10, 15, 20 years ago, and we can't all go back and update every blog post that we have. There's just a lot of stuff out there that's no longer current, especially as new versions of SQL Server drops. We're going to be demoing with SQL Server 2016, 2017, and Azure managed instances. All the demos that you've seen on here in Eric's database are in SQL Server 2017. So it's not like we're purposely using some old busted version of SQL Server in order to demonstrate problems inside the query optimizer.
Well, we do have some other questions. When you have a query that uses fetch offset for paging loss of rows, lots of rows, I think he means, how can you avoid sorting?
Oh, that's such a good question. Supporting indexes make a huge difference. If you tune indexes in order to support the query, you can end up doing less reads and less sorting as well. To see the exact queries where it really comes in, because sometimes there are sorts you just can't avoid. I'll give you a classic example. If I say, not only did we sort by post type ID, but let's say we wanted to order by count star descending. Show me the most popular post type IDs first. SQL Server has no way of knowing what the most popular post type IDs are going to be until the query finishes. It's going to have to do a sort in order to execute that. Another way is when you're joining multiple tables together. If you join 2, 3, 4 tables together, then SQL Server is going to have to go through and sort some of the output if you're trying to do complicated sorting across the joins in multiple tables. So here's the perfect example. So we have this sorting on, or no, we have this group by post type ID. But if you want to order by count star descending, you have to do that sort afterwards. For those of you who had trouble trying to read my poker face too inside here when I was like, don't ever do anything that has sorts inside there. A lot of this is our little delivery mechanism here to go, the things that you think are important really are no longer important or not as important anymore. And it's not across the board. Some stuff still is.
All right, here's another question. What's the best way to find missing indexes?
Ooh, I am, of course, partial to SP Blitz Index. It's a totally open source, licensed under MIT open source licensing. SP Blitz Index will go through and read your index usage DMVs, the missing indexes, but the quality of the index recommendations that come out of there is only as good as what's in the missing index DMVs. Pinal Dave, who's presenting later today at the 24 hours have passed, I believe he's presenting later today at the 24 hours have passed, likes to say that the missing index requests are kind of like like appetizers at a restaurant. They give you a starting idea of what you should do, but it's not the whole meal. What you want to do is learn how to interpret those and build even better requests. Unfortunately, there's not a script way to do that. It involves dealing with, I like how Eric says a missing index request is like a teenage cry for help. It's just a starting point where you want to go through and do deeper analysis. If you only have an hour a day to go through and do performance tuning or an hour a week, the missing index requests aren't a bad place to start. You just need to go in understanding where the requests come from and how they work. For example, the field order that they recommend, it's not intelligent. It's just a comma delimited list of fields. And it's based on the field order in the tables. It will recommend the first field first, the second field second, and third field third. It doesn't go 3, 2, 1. It goes in the order of the fields in the tables. Nothing to do with selectivity, nothing to do with how important they are in the query. Just all the equality fields are sorted by field order, and then the inequality fields are sorted by field order. The more you start to peel back the covers of how that works, you're like, oh my God, I definitely should not put this in directly.
Here's another one, but wouldn't you tune an index for each query?
You know, it's funny that in a perfect world, if I had a read-only database, I could afford to handcraft an index for every single query to make every query go as fast as possible. In an imperfect world, people are doing inserts, updates, and deletes against the data all the time. And the more indexes that you add, when you go to insert one row into a table, you have to update every index at the same time. SQL Server doesn't have a concept of asynchronous indexes. All the data is consistent at the same time. So if I have one index on a table, an insert is fairly straightforward. If I have 20 indexes on a table, I'm effectively asking my storage to do 20 times more work on every insert, update, and delete. I know a lot of database administrators who see 15-second IO warnings inside their error log, and they go yelling to the SAN admin, "Your storage sucks. Why don't you get this thing to go faster?" And then we open up and look at their tables, and they all have 50 indexes on them. I'm like, hey, you could cut your storage performance requirements by 50x right now if you go through and drop these. What? Are you kidding me? Generally speaking, I'll tell people I have a 5 and 5 rule. I aim for around 5 indexes per table, each with around 5 fields or less. So to repeat that, around 5 indexes per table with around 5 fields or less. 0 indexes is the wrong number, because then every time you read stuff, you're doing a table scan. 100 indexes is the wrong number, because then every time you do an insert and update and delete, your server's falling over. So this is just a starting point rule to help people. The only reason that I have this number is because I have 5 fingers on this hand and I got 5 fingers on this hand. If I would have been bad at shop class, if I'd have sawn the accident off with sawn the thumb off with Mr. Jackson, I had a saw teacher or a industrial shop teacher who only had 4 fingers. I would have had Brent's rule of 4 indexes or less and 5 fields or less per index. And we all could have laughed about my accident in shop class. It just so happens that I end up with 5 and 5. So there's where that rule comes from. I'm comfortable bending it a little bit. It's just a question of how much you can afford to bend it. And sometimes even 5 is the wrong number. If you end up in a server where every insert, update, and delete has to go blazing fast, then sometimes you have to go with less indexes, or sometimes you invest a ton of money in hardware and you can afford to have more indexes.
Does the 5 fields or less account for include columns?
Absolutely. Does the 5 field or less include includes? Yes, because every additional field that you add gets stored on the 8K pages for the leaves exactly the same way, whether they're sorted or not. The example I always give people, I'm going to offend somebody, I'm sure, by tearing a page out of the book. If I have to go through and update an index, if I update someone's last access date or something, I'm going to have to read that 8K page up from disk, change it, and write it back down to disk. That's the same whether the field is just included, I still got to read it up, write it, and then write it back down, or whether it's sorted in order. It's going to take up the same amount of space on the 8K pages for the leaves, and it's going to incur a whole lot of work either way on my inserts, updates, and deletes. So I just don't want people to think that includes are magically delicious and free.
And for a small table, less than 1,000 rows, I assume, is it better to leave it as a heap table?
That's a really interesting question. And in terms of, is it better to leave it as a heap? One of the biggest problems that I see running into is that heaps have this forwarded fetches problem. Say that I've got this 8K page and it's absolutely chock full. There's no space left on the page. And there's a person on this page who changes the city that they're in. Say that they move from Dublin, Ohio to Atchafalaya, Louisiana. So I have this tiny little Dublin here and I need to widen it to Atchafalaya, Louisiana, but there's no space left on the page. What SQL Server will do is go pick up that person and move them to another page, assuming that we have a heap here. If I pick them up and move them to another page, I leave a forwarded pointer behind. As SQL Server's reading through this page, it hits the forwarding pointer, does another 8K page read, and comes back. It can end up meaning a whole lot more 8K page reads in order to scan through a table. Whereas if you had a clustered index, SQL Server simply tears the page, puts some of the data on one 8K page and puts some of the data on another 8K page. Yes, there ends up being space empty issues. You talk about fixing that with fill factor, with defragmentation. We'll talk about that in the class. But at least it's relatively self-managing as opposed to a heap, which never cleans itself up. There are edge cases where I see heaps being faster, but if the table sticks around, if you do updates or if you do deletes, that's generally where I'm like, you probably, as Beyonce said, if you love it, put a key on it.
Um, how would you compare clustered column stores table versus B tree plus non-cluster column store in our environment? I noticed better execution plans produced with the former.
Oh, clustered column store. So Columnstore is different in that it's really good for data warehouses where I've got these big, ginormous, wide tables. I've got tens or even hundreds of columns in these tables, and I can never predict what people are going to filter for. I can never predict what they're going to group by. I can never predict what they're going to order by. There's just no way to index these tables. Plus, they have a lot of repetitive data in each column. It's the same data over and over again, like sale date or item number, and it's the same stuff over and over again. For this, Columnstore is a better way to store the data and a better way to retrieve the data. But I just want to emphasize and drill home that very often when you see them do smoking hot performance, just fantastic query performance and fantastic compression, it's more towards reporting or batch-oriented workloads where we tend to load a lot of the data in at once and then scan it all day long and write truly horrific scans against it. It's not as good of a fit for frequent small insert, update, and delete operations that also have point queries in them, like just go get me Brent Ozar's display name, or just get me Erik Darling's purchases. If you're frequently going in and doing very small point queries, not as much doing reports, then clustered column store indexes don't make quite as much sense.
Okay, what are your thoughts on the indexes recommended by Querystore?
What are my thoughts on indexes recommended by Querystore? I love the idea of Querystore in that it's like a black box recorder for MySQL Server's workloads. The indexes getting recommended from that, though, they're not a lot smarter than what you're seeing here. It's the same basic contents. But where Querystore comes in amazing is it starts to show you the queries that want those indexes, because then you can tie those together and go, here's the hint, here's the query. Now let me go use it as a starting point, as the teenagers cry for help, over in my development environment to create different combinations of indexes and see what works best. Plus, Querystore shows you the amount of reads and CPU time that query was doing over time. So then you can see what it was performing like when it was running. However, they are just a starting point to go work with because they have the same kinds of problems where they're recommending by field order. I'm not a fan of taking those exactly as is and applying them. They'll also recommend making wider versions of indexes you already have and narrower versions of indexes you already have. So it's where it comes in time for a human to go do that 5 and 5 tuning to figure out where I can get the right amount of indexes. Also, just the Querystore recommendations, they don't take into account the impact of inserts, updates, and deletes on a table. They may tell you, you should add an index to improve this select query right here. But the select query was run just once by Bob in accounting, who happens to have SSMS access directly to the SQL Server. And he only ran that query once, and he only runs it on Fridays, and he shouldn't even be running it in production anyway. I don't want to slow down my entire workload just because Bob has access to SSMS.
All right, so for those of us administering SQL 2000, does SP Blitz Index work for older versions? I have one of those too. So.
Oh my God. So the way that I usually approach that with management is that I'll say, on unsupported versions of SQL Server, there are things I can't do for you. There are tools that Microsoft didn't include in the box, and no one is building now. 2000 is 18 years old at this point. I don't have a problem with people running it, but I'm just like, at this point, and I say this to our clients as well, if performance and availability matters to you, like that you would pay me to go fix it, then we need to be on a supported version of SQL Server. But no, our scripts don't work on 2000. They don't even work on 2005. My personal feeling, and I've said this to people to companies that have tried to hire me as well, if Microsoft won't support it, I sure as hell can't. Like, I'm not more powerful than Microsoft. So as Eric is pointing out, you have a time bomb already on 2008 and 2008 R2. Both of these are going to be out of support next year around this same time. So this kind of helps to send that flag to management of, Not only do I want to make sure that my SQL servers are under support, I want to make sure that my skills are still in support. And if I'm wasting 1 minute of my time on an unsupported SQL Server version, it's a time bomb for your skill set.
All right, this may be more of a comment. Scripting of index analysis is called AI, perhaps also known as the automatic query tuner, at least in Azure. Yeah. And
Absolutely. This is one of those where Microsoft really, you have to keep in mind who's saying it and what they're trying to pitch you. Microsoft wants to say, hey, come to Azure, we'll do all the work for you. And in a sense, they're right. Because I bet a lot of us, and the 300 people who are in on the webcast, I bet a lot of us don't have time to tune indexes. And I bet you have a lot of databases that, let's be honest, you don't really care about. Or you can't be, you don't have enough time in the day to go through and care about them. That's where it's just wonderful to offload it to Microsoft. And if they make the same bad decisions that we're getting inside these missing index requests, who cares? It's still better than nothing. You know, it's still just at least some kind of breadcrumb trail for your indexes, which you weren't able to have before. The thing that I'll caution you with is, of course, the same reason that you see people bumping into problems with the missing index DMVs, you see people bumping into problems with the artificial intelligence tuning as well. It's just that you're putting your low-end workloads inside there today. 5 years from now, 10 years from now, that'll be a different story. We'll have automated index tuning taking care of a lot of the basics. But of course, there's always going to be people out there who insist on doing heaps and insist on doing the kinds of queries that we show in here inside the webcast. And ain't no amount of artificial intelligence is going to fix that stuff.
And finally, can the robot be taught interpretive dance?
The robot is very good at interpretive dance, but the thing is, it's very slow motion and it involves weights. So he tends to push up large amounts of weights. And I've gone through these things called gyms where people seem to be doing it in sync with each other. They're lifting these big monster things. I don't go in there very often because those people look like they could carry me and throw me out into a dumpster because clearly I do not belong in there with this body.
All right, well, that's about it. Click, click, click. But stay tuned for the, thanks, Brent and Eric, that was great. And the next coming up is Jason Hall with our open source databases on your radar.
Thanks, everybody. Adios.